Hello everyone, welcome back to another video for the series. I'm Yu, and today I brought a very exciting algebra problem. Yes, and the reason why I'm setting my intro like this is to boost where I came today. So in South Korea, today is National Foundation Day, which is Gaecheonjeol. So it's the day when the Gojoseon was first formed, and then we will have like the weekend and then a long Chuseok holiday. So it's gonna be a super long vacation for most Koreans. And that's why our family, like the entire family, decided to come to Gapyeong and then borrow a pension to like reunite, I guess. Yes, and I'm here at the attic, and it's such a beautiful place. Just look at it. So this is the view that I'm currently looking at right now. It's a wonderful place. And the reason why I'm showing this attic is to like show off this place. Like I have the privilege to solve math problems in this beautiful place. I will be solving math problems here. I'll be studying here. It's such a beautiful place. I have the privilege to just study in this beautiful place. So I think when I grow older, when I have the ability to live on my own, I think I'll find a house with this kind of beautiful attic so that when it rains, I can hear the raindrops and like solve math problems. It's just the most beautiful thing that I could think of right now. And unfortunately, it's not gonna rain today. And it's not gonna rain tomorrow either. It's not gonna rain. But it's okay because I still got this beautiful view. I'm pretty sure it will darken in like an hour or so, but I still can enjoy my time right now. And today I'll be making my math videos right here. Please enjoy. That was for the thumbnail, and let's go. Yeah, so this is the problem that I mentioned. Let's determine all functions such that, yeah. So after looking at this problem, the first thing, like the very first thing that I did is let x equals y equals 0. That way we have f of 0 equals 0 minus 0, which is 0. And then the next thing that I did is I just noticed that this like equation is almost symmetric. It's not symmetric, but it's almost symmetric. So what we can do here is write that and then switch the position of x and y like this. I think I missed something. Yes. So the reason why it's perfectly fine to do this is because notice that if we substitute like 1 and 2 here, we can also substitute 2 and 1 here, and that's just what I did here. So because x and y have the same limit, like I would say boundaries, we could also like switch them like every time. So every time we like substitute like a and b here, we can also substitute b and a here, and that will lead to the same equation right here. So the first one and the second one will always work. That means these are all true. So let's add them to cancel these two terms. That way we get x squared is equal to negative f of negative x squared plus y squared. I just switched these two. And because negative 1 times this thing is equal to that, we could infer that f of x is odd. And the next thing that we could do here is just substitute 0 here. So substitute like let y equals 0. Why not? That way we have f of x squared equals x f of x, and doing those things again, we have f of x squared minus f of y squared. So let a equals x squared and b equals negative y squared. That way we have f of a plus b equals f of a. Because this is odd, we can write it as f of a plus b. I think so. Yeah. And this is a very famous Cauchy equation. So we could, therefore we know that f of x equals c of x for constant c. So that's our solution right here. But I realized that the official solution had more to this. So I just know this Cauchy equation and then just stop right here. But I realized that the official solution and had more things to add here. So I'm going to share what they did. And I think they're both really brilliant. And they just started with the common fact that f of x is odd and this thing is true. So here, what they did is let a equals to t and b equals negative t. It's not the exact same thing that they did, but I forgot what they did exactly, but I think this is correct. So I'm just skipping the main point. So because this is odd, we can spit it out, I would say. Yeah, we could spit it out. Yeah. So equals f of 2t. So this is true. Now let's substitute let a equals x equals t plus 1 and y equals t. Then we have f of, substitute right here, we have in the first equation 2t plus 1 equals t plus 1 f of t plus 1 and minus t f of t. And let's use this property right here. So this is t plus 1 f of t plus f of 1 minus t f of t. Notice that these two cancel out, so we have f of t plus f of 1. So this one and this one cancels out, so we have plus t f of 1. And this is, let's switch this thing up like this, plus f of 1 equals f of t plus f of 1 plus t f of 1. Cancel that, and then let's use this one. So 2f of t equals f of t, t f of 1. Therefore, we have f of t equals t f of 1. Nice. Just because f of 1 could be any real number, we could find that t f of t equals cx for, and c is just f of 1. And that's a very common solution for Cauchy equation. So we actually got the same answer. And the next thing they did is, it was just so brilliant that so they just utilized this x right here. I don't know how they came up with this thing, but pretty amazing. Because add them, we get x, subtract them, we get 1, multiply them, and then that's the same thing as x. So this thing is same as f of 2 plus did I do something wrong? Like this, And then notice that because f of x is odd, you can spit out oopsie. Oh, I think it would be better to include them just to avoid x plus 1 squared. Yeah, like this. And I think what we should do here is we should try and utilize this fact right here. So notice that we have 2 right here, and no one really likes the 2 there, so we don't really want the 2 in the denominator. We just don't want it. So this is the same thing as okay, 2 times 1 over 2 times f of wait. Eh? No, this is right. Yeah. Square. No, let's use 4. Then we could do the same thing. No, this is not right. This can't be right. What am I doing? What am I doing? It's minus 1. It's minus 1 right here. Sorry. Like this. And then we're going to use this property right here. So just consider this whole thing as t. Then we're going to so just think of it as doing it twice. Yeah, so doing it once and doing it one more time, we get f of x plus 1 squared over 4 minus f of x minus 1 squared over 4. So here I think so sorry. No, I think wait, no. Yeah. So sorry. I think we can just continue from here because I just realized that let's use this one. Sorry, let's use this one. So using that we can like bring that thing out like x plus 1. And no wonder why it was quite strange. Like my explanation right here was different from like my memory, and then it was like, what? This is equal to x plus 1 times f of x plus f of 1 over 4 minus x minus 1 times f of x minus f of 1 over 4. Let's calculate them. This cancels, so x f of x, they cancel. How about x f of 1? they do not cancel. We have 2x f of 1 like this, I guess. Is it right? Yeah. How about f of x plus 2f of x? How about f of 1? That cancels, so over 4. And what was that equal to f of x? So 2f of x is equal to x f of 1 plus f of x. Therefore, f of x is equal to x f of 1. And that's the exact same result that we got. Yeah, so I think this problem is such a wonderful problem because this was like, after doing like the basic steps, we got Cauchy equation right away, and this is the direct application of Cauchy equation, I think, because I never tried a problem that was like that just gave us the Cauchy equation, but this was the first problem that actually did it. So I was actually quite like intrigued by that fact. And then here, I think like the clever substitution actually led to the answer. So not sure if I can do this because even so, if you're looking at my solution right now, I don't think the grader will give like full credit for it, because even though everyone knows that Cauchy equation has this one, like this solution, we still need to prove that this works for our f here, f of x here. So I think I might only get like partial points if I do this. So looking at this too, like this clever substitution gave us like better answer. And like I think this is just how did they came up with this thing? Like it's just amazing. Yeah. So that was it for today. I hope you enjoyed it, and tomorrow I'll come back with another very fun and interesting problem. Thank you, and see you tomorrow. Bye.